Hi everyone, in this video we're going to go through the difficult questions from 5G, so questions 6, 7, 8, 9 and 10. I'll try to be as quick as I can. This recording program is new to me, so I'm hoping it doesn't glitch because I did a video yesterday, got about halfway through and it died on me. So I'm starting again. So let's do a little prayer beforehand that everything works well and you get what you need out of this video. So if you need to at any time, fast forward, but I'll try to move as quickly as I can through the questions, only because I'm conscious that I do tend to waffle on. Anyway, let's move on. Question 6. So with these questions, as soon as I start seeing, let me just get a pen, 3 significant figures or 1 decimal place, and I don't really like that pen, so I might see if I can transfer, oh, go away. Can I not get rid of you? Are you going to keep drawing? How do I get rid of you? Do I go escape? Yes. Okay, isn't that funny? All right, I'm going to just use the one in Word. It's so much more user-friendly. All right, 3 significant figures and 1 decimal place. I just think, well, you can't do that with logs unless you're using a calculator. So I would do a straightforward solve with these, to be honest. They're not hard to solve. On your calculator, you just go into solve, type them in, and Bob's your uncle. So you know how to do that. So I'm just going to show you the difference though between significant figures and decimal places. So for question A, your answer becomes, so we're solving for A. So A is equal to 0.54399, and obviously the decimal places continue. Now, if you're rounding to 3 significant figures, it's different to 3 decimal places. Now, sometimes it could end up the same thing, all right, but you need to remember that they are actually different. So significant figures, we ignore any leading zero. So you can see here, we're starting with a 0, so we count then the non-zero numbers. So we've got 1, 2, 3, and we're going to do our cut there. And then this number decides whether we round up or we round down. Now, if it's 5 or more, if this number here is 5 or more, we round up, which it is, because that number is closer to 0.544 than it is to 0.543, okay, because of that 9. So if you think about, you know, if you're measuring your height, I'm 179 centimeters or 1.79 meters, and that's closer to 180 centimeters than to 170 centimeters. So just think about it, you know, think about your rounding, all right? Were we rounding up or were we rounding down? So that's 3 significant figures, also the same as 3 decimal places in this scenario. Now you'll notice in the pink, I've done more decimal places than we've needed before I did my rounding. That's an extremely good habit to get into for your year 12 exams, because, or your, 3, 4 exams, because there's a thing called a rounding error. So if you've made an error that's clearly a rounding error, they try not to penalize you. So if I wrote what was in pink and then I incorrectly rounded that to, let's say, 0.54, I thought, 3 significant figures, there's 3 figures there, done. So technically my answer, I didn't round it correctly, but my working is fine. And that's why it's also good in methods to show your working out. So let's put that 4 back there. All right, so with question B, we're rounding to 1 decimal place. So for B, we're solving for, okay, and I've done this before on my calculator, so I'm not just don't know this off the top of my head. All right, you don't need to do heaps of decimal places. It just depends on what you're rounding to. So this one, we're only rounding to 1 decimal place. So I do my cut there. This is my deciding number. So K is equal to 549, and then the 3 stays as a 3 because that 2 means we round down. So we're rounding down effectively to 30, but we don't write the 0 there. Okay, now that's decimal places. If I was doing significant figures, your significant figures would be, and you start at your first non-zero number. So our first non-zero number is 5. So if we were doing 3 significant figures, it would just be 549. All right, there's no decimal places because I've already done my 3 figures. So you can see there how the two are different, whereas in part A, they actually worked out to be the same thing, which can be the case sometimes. All right, again, just putting down as many decimal places as you need. So if you're rounding to 1 decimal place, probably just add a couple of extra. You don't need to put them all in. All right. Now, in your textbook, when it goes through the solutions for these questions, they actually have the working out, but then you eventually have to use your calculator anyway, because there's only so far you can go. So obviously you'd get an exact answer. So let's have a look at doing question A without the calculator. All right, and I've got my notes here to refer to. So I did these about 2 days ago. So if I'm pausing, it's just me trying to figure out what I've written. All right, so for the first, so we're just going to do part A, just so I can explain it. So we'll do it in blue. All right, so, whoops, can't see part A, there we go. So we've got A times log base 2, 7 equals 3 minus log base 6, 14. Just make sure your bases are little, all right, and your argument, so the 7, is the same size as your log, and here are the 14. And maybe get into the habit of putting it in brackets, because as I have said to you, if you had something, let's say, why do I keep going off on these tangents? Let's ignore that. All right, so let's say it was 14 minus x, and that was your argument, the whole thing. If I didn't put brackets around there, it would look like you're only taking log of 14, not of 14 minus x. So just keep in mind. So, you know, putting brackets around it doesn't hurt. Your calculator does it as well. All right, so the trick with this one here is, well, we want to get everything into log. So we can see we've got this 3, first of all, that obviously is not written as a log, but you can write numbers as logs. So just like I could write, you know, the number 81 as 9 squared, or I could write it as 3 to the power of 4. All right, so we can write 3. Let me just get rid of all that. And let's just do it on the side here. Whoops. Okay, so 3 is equal to, if we want the base to be the same, so 6. So we need to work out what x is going to be. So basically this is when we interpret this, when we solve for x, take base 6 of both sides. So 6 to the power of 3 is equal to x. So 6 to the power of 3, again, something like this, you probably couldn't do it without your calculator anyway. So x is equal to 6 times 6 times 6, which is 216. So instead of writing 3, that is the same as log base 6 of 216. Okay, so I've just written that number 3 as a log of base 6. All right, so I'm going to just rewrite what I've got there. All right, so now that I've got my 2 logs that are the same base and we're subtracting, so we can use our log laws to bring them together. Just leaving that left-hand side as it is. I'm not touching that for now. All right, so log base 6 of 216 over 14, and that does simplify as well. So I'm just going to do the simplifying now, so I don't have to write it. So it's the same as 108 over 7. Just make sure that looks like a 0, not a 6. All right, and then A is equal to log 608 over 7 over log base 2 over 7. And, you know, you can change that log base 2 to a log base 6, but you're going to have to eventually put it into your calculator anyway. So to do that, you do your change of base. So we're going to be doing change of base a few times here. So I might just quickly show you. All right, so we've got log base 2 of 7. So if I wanted to change the base to anything, absolutely anything. So in this case, I'm going to do it base 6, so they're all the same. And whatever is on I always say on top, but your argument goes on top. So that's going to be a 7 here because it is just a fraction, and then log base 6, and then whatever is on the bottom or your base goes on the bottom of the fraction. So there's a few questions we're going to do here where we're going to change the base. So you can then substitute this in for your denominator, but you're still going to have to put it into your calculator. So for this one here, there's no cancelling. You do have to end up with a approximate answer, you know, 0.544. There's no way you can do that without a calculator. So we'll just end there, and then future questions we will be using change of base again. So it's not the first time we're going to see it. Not the only time. Sorry, it is the first time, but it's not the only time we're going to see it. All right, let's move on to question 7. All right, so prove that if log base r of p equals q and log base q of r equals p, then log base q of p equals p times q. All right, so just having a look at this, you can see there's no r's in that equation. So, and there is in the other two. All right, so I'm going to manipulate them to get rid of the r's basically. So for the first log, we've got log base r of p equals q. And just be careful with your q's, make sure they don't look like 9s. And sometimes students get p's and q's mixed up. All right, so they kind of look the same. I mean, it's a very valid mistake to make, but just be careful. Okay, so if I take base r of both sides, I'm going to have p is equal to r to the power of q. And then for my second log, so this one here, you can put it in brackets, even though it doesn't have it in the question. All right, so to get r on its own, I'm going to take base q of both sides. And you can see I've got r equals the q to the power of p, so I can just substitute that for this r. So going back over to this side, and I'm going to do it in blue. So instead of having r, I'm going to put in q to the power of p. And that is all to the power of q. Now, using your log laws, I'm going to go back to black. Oh, it's a bit slow. You're just multiplying. So if you got a power to a power, you're just multiplying them. So it's going to be p equals q to the power of pq. And remember, we want it to look like this. So at the moment, there's no log in this expression really. But if I want to get rid of this q, I just take log base q of both sides, and you can see what I want. There's the q. So log q of p is equal to pq. All right, so when I take, actually, let me not skip that step. So if I take log base q of both sides, so I did the left side, but I kind of skipped pq. Oh, sorry, looking at the wrong thing. Hey. All right, so it's q to the power of pq. All right, so this, because your base and your argument are the same, they cancel each other out. So that is then just equal to pq as it asked in the question. So we've just proven it. All right, moving on to question 8. I might just have a quick sip of water. All right, so in question 8, let me just find where my notes are in my book. All right, the hard one is really C. So we'll quickly get through A and B, and then we'll do C. So question A, all right, I'm going to just remind myself that U is equal to log base 9 of X, not Q. So make sure it looks like you don't think it looks like a Q, especially because we've just done a question with lots of Q's in it. All right, so we need to get U in terms of X. So we want to get X on its own. So I take base 9 of both sides. So base 9 of log base 9, they cancel out. So X is just equal to 9 to the power of U. So quite an easy one there. Let's do B. Log base 9, 3x. And I'm just going to write U again. Sometimes I sit there thinking, what am I doing? And then I forget in the question it told me U is equal to log base 9 of X. All right, so we want to see if we can find this, because remember U is equal to this. Just wondering why that's flashing on me. All right, don't know why it was flashing. We'll keep going. So we want to get log base 9 of X, and we can see that the only thing getting in our way is this 3. All right, we've got a 3x in our argument, but where we want just an X. So knowing our log laws, we can actually separate them. So your very first log law, if you want to go back to your log laws, all right, so we can rewrite that as log base 9 of 3 plus log base 9 of X. So then you can see, oh, that's the same thing. So then I just have to write U, okay, because we're getting it in terms of U. Now the log base 9 of 3, remember that is means 9 to the power of something. So let's call it M is equal to 3. So if you wanted to, even though it's not a hard one to do, so you could probably already tell it's going to be a half. But if you're solving, just get your your bases in the same number. So our base is 3. So 9 can be written as 3 to the power of 2, and then we've still got that M there. So 3 to the power of 2M is equal to 3 to the power of 1. Now that your bases are the same, 2M is equal to 1, so M is equal to 1/2. Or you could already tell that M is going to be equal to 1/2 because square root of 9 is equal to 3. And hopefully you know your rational indices. Okay, so this is going to be just 1/2. So this expression in terms of U is 1/2 plus U. All right, now I'm going to just rub off what I've written over here just so I can fit part C in. All right, and I might just, actually no, I was going to rewrite that, but because some people will just look at my notes and not really watch the video. All right, so part C. Whereas videos are so entertaining, why wouldn't you watch them? All right, so we've got log X of 81, and remembering that log base 9 of X is equal to U. All right, so let's first look at, I'm just looking at my notes. All right, so here we're going to change the base again. So I've got a base of X, and I really want it to be base of 9. So I can change this log base X of 81. Or actually, what am I doing? Just make sure I've got it. Hold on, I'm going to change it the other way, sorry. I'm going to change this log base 9 of X. Sorry, I'm going to focus on this first. This is why I did this 2 days ago, and I've got to keep referring back to my notes. All right, I'm going to see how I can change this to get it, sorry, when I say this, I mean this part here, to look like this. All right, so we're kind of manipulating it. All right, so first of all, as I said, we've got to change the base. So I want the base to be x. So you can see the x here. All right, so remember changing your base. Basically, we want the base to be x. So we've got on our numerator, log base x over log base x on our denominator. And then just with your argument, what goes inside that bracket. So the x is on top, so that goes there, and the 9's on the bottom. All right, so we're just changing that base. So we know that base 9 of x is equal to u. So I'm going to put u back over onto that left side. And let's just try to change the right side so it looks like log base x of 81. All right, so on my numerator, because my base and my argument are the same, that changes to 1. And then I've got log base x of 9 on the denominator. Still doesn't look like what we want. We're kind of halfway there, but we just want this 9 to look like 81. So to do that, I know that 9 squared is 81. So to do that, I basically need to multiply my denominator by 2. All right, because knowing your log laws, 2 times log base x of 9, I can shift that 9 to be the power of, I can shift that 2 to become the power of 9. I might do that in a step to show you. All right, so I do have to multiply it by 2 over 2 just because I can't change. If I just multiply the denominator by 2, I'm kind of, breaking a, not breaking a rule. I'm changing the equation. But multiplying it by 2 over 2, I'm basically just multiplying it by 1. All right, so we've got 2 over 2 log x9. And knowing your log laws, this 2 can be shifted up to the top here. And that's where your 81 comes in. So log base x of 81. All right. Now we just got to manipulate it because we want log base x of 81 to be in terms of u. All right, at the moment I've got u equals, so we just need to switch them around. So when you are doing that, you can just switch your number with your, whatever value is here on the left with that denominator. If you don't believe me, you can do it in 2 steps. You can multiply by the log and then divide by u, and you'd get the same thing. All right, so log base x of 81 is equal to 2 over u. All right, so quite a tricky question, and that thing's flashing at me again, so I'll just keep an eye on it. All right, question 9. Where are you on my sheet? Okay, so solve the equation. Yes, a little bit delirious. It is only 11:30 a.m. on Wednesday, so it's not late or anything. Okay, so we've got to solve this equation. So let me just look at my notes. What did I do here? Why did I do that to the power of 16? I don't think that really matters. Okay, so we do have to have the same base. All right, so you can change the base to whatever you like, but just looking at my notes, I changed them both to base e. So see how you've got a 5 here and an x here. So probably good not to have the x there, but I'm just wondering why I didn't change it to a... Anyway, let's not worry too much about that. All right, so let's do our change of base. So we're going to change the log base 5 to the power of x. All right, so I'm just going to do a natural log. Okay, so remember, for change of base, your base can be anything, but whatever your argument is, kind of think of it, it's on top, goes on the top of your fraction, the base is on the bottom, goes on the base of your fraction. So that's the first log. Now, just rewriting this one here, the second one, as 16 log, log base x of 5, and then we can put the power of 16 up there. So I'm just going to do that as well. And good luck doing 5 to the power of 16. We can just leave it there. You don't need to actually do that. So again, natural log Make sure it's a little e. We're not writing the word loge. So on the top, we've got 5 to the power of 16, and then on the bottom, we've got the x. All right, and it's probably good. I think maybe I did natural logs just to, I can see there's some cancelling out happening. All right, so let's go back onto the left side of the screen. So instead of having this log base 5 of x, we're going to put in this. And instead of having on the right side this, we're going to put in this. All right, so little bit of music while we're waiting. All right. You poor girls, you missed out on having me during remote learning. I was very entertaining. No, it wasn't. Okay. So we can start looking at changing, this equation. So I'm going to do cross multiply. So we're going to multiply both sides by log base e of x. And then multiply both sides by log base e of 5. And this question 10 is going to be in the way, so if I can just move you down a little bit. All right, so effectively I've got here two log base e of x. Okay, there's 2 of them. So we can just write x squared and going to bring that 16 back out the front. All right, and then we've got 2 log base e of 5. So we're going to square that. All right, I'm just looking at my notes. All right, so to get rid of the squareds, we can just take the square root of both sides. All right, so the square root of this left side, we've just left with the x. Square root of 16 is plus or minus 4, and log 5. All right, you don't need to do plus or minus of both sides because, yeah, this only doing it once will kind of, you've taken that into consideration. All right, then let's just move that 4. Whoops. I'm just looking at my notes as we go, so I don't miss anything. I'm just going to put plus or minus the 4 here. All right, so then I can take base e of both sides. Because they're log base e, they're the same base, then I'm left with just x on the left side, and on the right side 5 to the power of plus 4, or 5 to the power of negative 4. Now, again, you're getting quite high with your indices. You probably could do that. So 25 times 25, so that's going to be 625. And because this is a negative power, that's just going to be 1 over 625. In an exam, I think they would actually just accept it left in index form with such a high power, 5 to the power of 4 and 5 to the power of negative 4. And sometimes they would specify it in that format. But I do think you should be able to do 25 times 25, even if you just did a little bit of long multiplication over the side like this. All right. Okay, so quite a long question. What was that, question 9? All right, moving on to question 10. Where are my notes for question 10? All right, I think I had a bit of working out here. Let me just find where I went, because sometimes I approach questions several ways until I'm like, oh no, this is the way it's done. Okay, so q to the power of p is equal to 25. Find log base 5 of q in terms of p. All right, so qp, make sure your q looks like a q, not like a 9, is equal to 25. So if I take log base q of both sides, all right, p is equal to that. And then I just need to change this log base q of 25 into log base 5 of q. So let me just manipulate a few things. All right, so 25 is the same as 5 squared. And all right, I did pause just to have a look at my notes, but sometimes I think I should just keep going. All right, we want a different base. So see how we've got a base of q here. Oops, you're meant to be my highlighter. We've got a base of q here and we've got a base of 5 here. So we need to change that to be a base of 5. All right, so setting up our change of base. So we're changing it to a 5, and you can just set it up like this. All right, so we know our bases are changing to 5. So I'm basically, the p stays on the left-hand side, and what is on the right-hand side, I'm changing the base. All right, so the 5 squared is on top. I'm going to leave it like that. And then the q is on the bottom. All right. And I'm just going to keep looking at my notes. All right, so then we've got base of 5 to the power of 5, they cancel out and we're just left with 2. And let me just go back up here. What are we doing? 5 and, oh, okay. Sorry, let me just show you what we're doing. I've got, I found p, but we want log base 5 of q in terms of p. So I just need to rearrange this equation. So we're just switching these over basically. So you can, if you wanted to, you can multiply by the log and then divide by p and you'll get the same thing. So log base 5 of q is equal to 2 over p. All right, so in this video, we learnt the change of base. We didn't cover it in class just because we ran out of time towards the end of term, but you can see some questions there where you need to change a base, and changing the base is not that difficult. Just remember, it changes into a fraction and your argument is kind of on top, goes on top on your numerator, the base is on the bottom, goes on your denominator. All right, I'll leave it there. Bye.